The PSK, or preserved key, is one of the three security methods used in OpenCAPIF, along with OAuth and PKA. This method consists of both client and server having a common key with which they can stabilize a secure connection. In OpenCAPIF, when an API that supports PSK is published, an invoker can discover it and make a security context creation request to use it. From the request, the information needed to derive the PSK is obtained: the master key, the session ID, and the interface information. And both the invoker and the CAPIF core function should derive the PSK. When both already have the key, the invoker must make a request to the AF to verify that it has access to the service that it exposed. In this request, the AF asks to the CAPIF core function for the invoker's security context that contains the PSK needed to validate the next requests. With this, the invoker could now make requests to the service using the PSK in the request header. The AF, for its part, will validate each request by comparing the PSK that it receives with the PSK that it has obtained from the CAPIF core function. This will be the flow that we will follow in the demo. But first, I wanted to explain a little how the PSK is derived. To derive the PSK, we need to first create a string using the information that I mentioned before. In this case, we have fc, which is a constant for CAPIF, is OX7A. Then we have PO, which will be the interface information, along with LO, which will be its length. And finally, we have P1, which is the session ID, along with its length, L1. With this, we can form the string S following the pattern fc plus PO plus LO plus P1 plus L1. And with this string, we can use the key derivation function together with the master key to obtain or derive the PSK. This is roughly how we are going to derive the PSK, but we will go into a bit more detail during the demo. Starting with the demo, the first thing will be to ask an administrator of the CAPIF that we want to use to create a user for us. The admin must log in using their credentials to obtain a token needed to perform their operations. As you can see here, if we make the request, we obtain the access token necessary to carry out its operations, and the refresh token, used to refresh the access token. The next step will be to create a user. For this, using the token that we just obtained and the endpoint create user, the admin can create it by specifying some user information. In this information, we find the username and password of the user that we want to create, which will be the credentials used to obtain the information necessary to use CAPIF. If we make the request, we see that the user is created successfully, and an ID is returning that identifies the user and will allow us to manage it. With the credentials, we can now obtain the information needed to use CAPIF and register an invoker in our case. If we make the request, we obtain the token necessary to register both invokers and providers, the CR root to validate subsequent requests since we will use certificates, and finally the CAPIF URLs. Now we will register an invoker to be able to consume an API with PSK. For this, we will use the token and URL that we just obtained in the getOut endpoint. We also need to specify some information about the invoker. The most important of these parameters is this one, the API invoker public key, where we need to enter a CSR or certificate signing request to obtain the certificate that will identify the invoker. In response, we found the invoker ID and the certificate that we are going to use for the following operations. Since we are now using certificates for requests, let's configure Postman to use them. In the settings, we have the certificates section where we can specify the CR root certificate that we obtain in the getOut request. And we also can specify the host and the invoker certificate that we just obtained, along with its key. With this, we will have everything configured and we could make the next request, which in this case is the discovery of APIs. Using the discover URL, we can make the request and see that we currently don't have any published API. So our next step will be to publish an API that uses PSK as security method. We are going to do this using a client that we have developed using the CAPIF SDK and the AF Security API service specified by 3GPP. This client will allow us to register a provider and easily publish an API in CAPIF while exposing it for consumption. Here we have the logs, which show the exposed endpoints. We have the check authentication and the revoke authorization of the AF Security API, the start client PSK to fully initialize the client, and finally the information to test the API. If we fully initialize the client using the user's credentials, it returns an OK response, and if we look at the logs again, we can check what has been done. We see that it has made the getOut request to obtain the token needed to register the provider. Then it has registered the provider to be able to obtain all its certificates. And finally, it has published an API with this ID, the ECE13. So, if we run the discover again as an invoker, we can find the API that we just published with its ID. We also find the ID of the AF that exposed it and the endpoints that we mentioned it before. These two are from the AF Security API. and the information endpoint that is the one we will use to test it. It's also important to note that it uses PSK as a security method. Once the invoker has information about the API that it wants to consume, they have to create a security context to use that API. However, since we are going to use a PSK as security method, Postman doesn't provide all the information that we need to create it. Therefore, we are going to use a Python script that performs all the necessary steps to create the security context and to obtain our PSK. This script needs our invoker ID and some information that we can obtain from the discover, as the AF ID that exposes the API and also the API ID. The script executes the CAPIF request to create a security context and obtains everything needed to create the PSK, the session ID, the master key, and the interface information. Using all of this, the next step is to normalize and convert the session ID and interface info into octet format, calculate their lengths, and create the S-string following the pattern OX7A plus PO plus LO plus P1 plus L1. We derive this string with the master key and using the key derivation function, and we finally obtain the PSK as a result. Once we have the PSK, our next step is to check if we can use the API. For this, we can use one of the AF Security API endpoints, the check authentication. If we make the request, we get an OK response that allows us to use the API. If we go back to our client's logs, we can see that it has made a request to CAPIF to obtain the invoker security context, which will be this one, where it is specified that PSK is used as a security method and said PSK is obtaining to be able to validate it. Now, the invoker can make API requests using the PSK that it created. So, we will use the information endpoint of the API and let's copy the PSK to make the request. We see that the request is successful and we get the simple information message. We are using the PSK security method. We can also try changing a digit of the PSK to see what happens. And we see that it tells us that the PSK is invalid and we cannot use the API. With this, we have been able to publish an API in CAPIF that supports PSK as a security method. And for this, we have used a client that, using the CAPIF SDK, has performed all the necessary operations to publish it. We have also registered an invoker with which we have seen how we can derive the PSK and use it to consume the API.